There's a lot of parallels between these design cycles that I argue are not coincidental. The tests that occur during natural selection tend to be very extreme, quite literally life or death. The tests that engineers employ every day can also be extreme. And not only that, they can also be quite bizarre. How strange would it be if if you looked out your window and saw your neighbors all intentionally crashing their automobiles together? You would certainly describe their behavior as bizarre. But when engineers do the exact same thing, the test seems very rational. And likewise, when we review the dreams that we have, they may seem quite bizarre. But when we start to look at them as tests, they actually can seem quite rational. For example, this dream this woman is having, when viewed as a test of her ability to cope with fear, actually that could be a really good test of her ability to cope with fear, a quite rational test. Going back to natural selection, while some tests are quite extreme, others are quite mundane. If the shape of an animal's esophagus isn't quite right, it may not survive. If it's the color of its plumage isn't the right shade of red, it may not be selected for mating. Some of the tests are extreme, some are quite mundane. Engineers, a lot of the tests they do are likewise extremely mundane, quite tedious tests. And as researchers have known, a lot of the dreams that are logged within a laboratory are quite mundane. Now, if you were to take this iterative design process that engineers use and plot it over time, you would get a curve that looks something like this. And it would start when the system is online, and during the first phase of design, it would be taking offline. And that's what I'm showing on the y-axis here is the degree of it being taken offline. And in the first phase of design, it's taking way offline. This is when the system is really taken apart and its most extreme modifications are made. So if this was a physical system, it might be taken apart, strewn across a lab table, things like that. If it was a software system, software engineers refer to a system as being gutted because it's really being taken down at its core. And then after the first phase of design, it goes into testing. And in the first test, you really effectively have a prototype. You don't have a functioning system, and you just lightly test it here. So the first phase of testing tends to be quite short. After you take your results from the first phase of testing, you go back to design, and here you're again making major modifications, but you're not quite as major as the first design phase typically. Then you do more testing, and here you have more of a complete system, so you do a little bit test for a little bit longer, more modifications, more testing, and then when you get to the last phase, you're really only tweaking at the last phase. You're about to bring the system back online, and you don't want to make any major modifications. If a manager, say, were to come to an engineer and say, I want to make some major modifications, it's the engineer's responsibility to say, you cannot do that. We're about to go live and it would be too risky. So right here, you only want to do tweaks. And then in the last phase of testing, you do your most major, most rigorous testing and for the longest period of time to ensure that it's safe, that it does what it needs to do. And then you release the system. This is what the sleep researchers see in the laboratory for the REM, non-REM cycles of the average person. And what I'm saying is that this maps nicely to what engineers see in their day-to-day design of thinking. So what I'm saying is that we're awake, and then in our first non-REM sleep, the brain and the mind go offline. They go way offline. And this is where the most intense modifications to the schemas take place. After the schemas are modified, REM sleep kicks in, and the schemas are really effectively a prototype at this point. So REM sleep tends to be short, and then all tests are done, and then the second phase of non-REM begins, where it's not quite as deep as the first phase, and the results of the prior REM sleep are implemented or taken into account while further modifications are done. More REM tests, more non-REM accommodations to schemas, and just the way an engineer would proceed, the mind proceeds. And then in the last non-REM phase, prior to waking up, the mind and brain don't want to make major modifications to its schemas because it's about to go live. And then you have your last REM sleep, which is where the testing for the last schemas before they are brought online occurs. And a lot of the characteristics of dreams kind of map nicely to this. The first REM sleep tend to be the most mundane dreams, and then towards the last REM sleep, just prior to waking, sleep researchers have observed that dreams tend to be the most bizarre and the most extreme in this case, which maps neatly to what an engineer would do, which is to rigorously test a system before it goes live, and then you wake up. So here's the mapping of the non-REM-REM cycle to emotional selection. The non-REM phase is when the accommodation or the modifications to the schemas occurs, and then emotional selection occurs during the REM period. Here is the way, here's the same mapping that we just discussed, only mapped to the cycle. So when you first fall asleep, you experience what they call slow wave sleep, where it's theorized that your neural networks are somewhat primed for learning. And then you have your non-REM dreams, which is where the accommodation to schemas occurs. Then you have what you call P waves, which solidifies somewhat of what you've the modifications to schemas, and then you have your REM dreams, where the emotional selection or the testing of the schemas occurs, during which the amygdala, which is a part of the brain that's responsible for emotions, is highly active, and it selects which modifications or which accommodations to retain and which to ignore, and then onset dreams are the dreams you experience just prior to falling asleep, which is the type of dream that would solidify the new neural connections that occur as a result of the schema accommodations. And again, this is in my paper. If you want to check out my paper, it talks about this in more detail, but I don't want to go into much more of it here. One of the interesting things, I have an engineering background, and when I describe my theory to engineers, they really pretty much get it right away. And interestingly, I find it more difficult to explain it to psychologists and psychiatrists. And it's not that I necessarily think that they would buy into my theory, but it's just I'll talk to them about half an hour, and then it just occurs to me we're talking about two different things. And what I've kind of realized that the way an engineer talks about testing and the way a psychologist talks about testing is really quite different. So what I want to do here is talk about the way an engineer views a test, and then that can be applied to the way the brain and mind would use tests to test its schemas. So as an example, I want to talk about during the 80s, NASA was trying to improve the survivability of crash victims during an airliner. So what they realized is that when airline or airplanes crash, it's not the impact of the crash that typically injures or kills people. It's the fireball that occurs afterwards. And so they were looking for a way to diminish the fireball so that people could survive plane crashes. And so they came up with this fuel additive called FM9, which eliminated the misting that occurs in fireballs, and therefore, or they hoped to eliminate the misting, which would reduce the fireball. So they completed FM9, and so how would you test that? You've developed this fuel additive for airliners that prevents, that tests their ability to survive, to not explode when an airplane crashes. So how would you test that? Well, as a former engineer myself, the only way I would know how to test it would be to get a very large airplane, fill it full of fuel, put the FM9 in the fuel tanks, and then crash the airplane. And that's really the only way to be certain that what you've done, it will actually work. So that's what NASA did. They took an airliner, they filled it full of crash test dummies, and then they crashed it in the desert, and hoping that it wouldn't explode, that it might break apart, but that it just would, the fuel would just pour out, and that would be the end of it. But this is what happened. It blew up into a fireball that took an hour to to put out for firefighters. So it effectively the FM9 didn't work.